For the evening, and we have a lot of cool experts who are building cool projects within the space here. So we'll learn a bit more about what these are and how are they helping with the Web3 privacy in this very first panel. So we have Chua from Automata, and we have Benjamin from iExec, we have Philip from SpaceCoin, we have Bernard from Oasis, and finally Joshua from Phala Network. And as for your moderator today, I'm Leslie. I'm from Marlin Protocol. So we do provide TE as a service, helping with the confidentiality and the verifiability aspect for decentralized AI, DeSci, and DeFi. So yeah, so let's get started. So I want to start with Benjamin. What are TEs? So, and how do you use them within your network? So, if you can share a bit more about that, that would be helpful.
Sure. So, hi everyone. So I'm Benjamin. I'm from iExec. For those who don't know iExec, we're a Web3 protocol that helps builders protect and monetize digital assets, their own or their users. So to answer the question, so TE stands for Trusted Execution Environments. They help, they're not specific to Web3 though, but they help processing in a secure enclave, any type of process in a reliable and secure way. The way we use it at iExec is that we implement it in all of our developer tools. And so we have what we call protected data. So I'll give it like a very easy example is Web3 Mail, which is our easy stuff for builders. So basically what Web3 Mail is a secure, private, and trustless solution where instead of the app asking for the user's email address, the user will do a protected data out of their email address, and the app will then have to process in a secure enclave that protected data to send an email at the user. And so that has multiple benefits. The app has never the email address. The iExec never has the email address. And the end user is actually able to have fully control on his protected data. If he revokes access, he's unsubscribed. He doesn't have to beg the application. So yeah.
Thank you, Benjamin. Thanks for the succinct summary of what TEs are. So yeah, moving on to Joshua, who is right beside me. Phala does take a slightly nuanced approach, wherein they also use MPC and ZKP in conjunction of TEs. So how do you see all of this coming together and make the overall platform trustless for builders? What is your take on it?
So my take really is like, how do you build useful applications that people want to use? For instance, us in particular, we have a cloud solution so that you can deploy any Docker image inside a TE. So this kind of like opens up a lot of like possibilities. And then when it comes to utilizing some more like privacy preserving technologies like MPC, or this helps with the like root of trust problem, where we can have like a key management service such that it can then take this like base image whenever you're launching this confidential VM, and it can go to the key management service and then fetch a key, and then that will be a representation of that CVM that is launched to the Phala cloud. So I think there's like a lot of like interesting things here, because that allows you to, one, have these confidential VMs have like upgradability. And then from there as well, you're also able to, build some tamper-proof applications that you're not really able to do today in Web3. So like, it really just opens up this new vector for the market. So where you're not only connecting to like Web3, but you're also connecting to the useful APIs that you want to connect to. Maybe you want to enable some sort of like verifiable connection to these endpoints with zk-TLS. It just makes it really easy to do all these like, plug and play types of moves. And that's where we're kind of headed in this situation for us.
Can you be more specific in terms of a real world use case that you are currently building so that it will be more relatable for the audience here?
Yeah, of course. So say like there's a T blockchain that needed some kind of expert in TEs to host their info, like we can support that. Another part is actual use cases. So the very first deployment on the Phala Cloud was TEE, which is an AI agent that owned its own account. The next one was my first client called AI Pool. And then that idea was, how do we do a fair launch ICO with an AI agent that can derive its own wallet within a TE and never and owns its wallet as well. So we probably on the day before Christmas Eve, it generated a wallet. We exposed the wallet to people to send in their funds, and about 2 days later, there's like $7.4 million there, and we are able to then do the launch of the token that gets generated, and then airdrop to all the participants that sent money to the agent in this case to get their airdrop rewards. So that's another one. Another one is a Rabbi. It's called Rabbi Shlomo, but this is the company's Kosher Capital. But essentially, this bot can do autonomous trades, and it posts on Twitter its trades, and it can manage its own fund. And then there's other ones like a betting, like it's more of like you send tokens to the agent, and there's an auto client that's checking the next say like a transaction that goes to that agent. So it's like, oh, it detects it, it generates a random number in the T, it checks to see if it's over 0.5, and then there it'll either reward the person that sent the money or they lose their money. So it's like kind of like betting in that sense. But there's plenty of use cases. I really like verifiable front ends as an idea, someone to push, and then also anything when it comes to letting research labs monetize things that are sitting on the shelf.
Cool. Thanks, Joshua. Going back to Bernard. So Oasis is a privacy L1 that uses TEs, and you split both the consensus as well as your paradigm layer, right? How do you guys fit in TEs into this whole paradigm to ensure scalability as well as privacy? Would love to know how the TEs play a role in this entire paradigm. Yeah.
Sure. Thanks for the question. We have the consensus layer is more or less, it's a consensus layer, is very thin layer, but like every node runs in a TE. For that, like we can have like a verifiable consensus. But a more important part is obviously the paradigms, where like more the action is. Like the consensus layer is just for. Yeah, sure. The consensus layer, as I said, like it's just for the staking and actually for depositing to the paradigms. The paradigms stand actually for parallel execution. So like you can run parallel multiple execution environments. Like the most prominent example for us is a Sapphire, which is a confidential EVM. So like it's just a normal EVM like Ethereum or Base or Optimism. But we have enhanced privacy features, especially because we run all these nodes in TEs. So like we have the whole contract is encrypted, and like the computation at the end of the contract runs in the TE. So like it's verifiable in this black box where nobody had access in it. This opens up a lot of possibilities for privacy. You can actually have kind of smart privacy. You can define public variables which everyone can use, or like you can actually guard them with modifiers. So like only special people can use it. Like you can give auditor roles or other stuff, so you can build smart private ERC20s where like you have like kind of the privacy you have like in the current banking system, where the bank maybe sees all the account details but the normal public cannot see, which brings a bit back a bit like your financial privacy, which like it gets a bit lost with all the public blockchains, where like if you tap your crypto debit card, everyone can see you spent with this account, or you have 2 million on your account, and so maybe the kiosk shop like says like another guy, hey, follow this guy home and reach in his house. I mean, that's we have to be careful with your financial privacy. But like as like this also limits a bit only to a blockchain. We also like use TEs nowadays very close coupled to this Sapphire blockchain, that we can also get like more like of compute from off-chain, like to get off-chain data, but also like, yeah, run then AI agents connected directly with our blockchain. Yes.
Thank you, Bernard. So moving on, Philip, you guys are building something cool in the space, like satellite and sovereignty of satellite. So that is like pretty cool stuff. Something that the industry is not used to. So would love to know how are you guys using TEs? What is the specific element of TEs in this entire protocol that you have designed, and how is it helping you out?
Yeah, thanks for the question and thanks for allowing us to be here. It's a definitely interesting discussion. And when it comes to the activities that we as a space coin are aiming to achieve is, of course, build a robust L1 that will be running on the satellites, and the TEs play a very crucial aspect that, especially due to the part of the physical isolation, allow us to firstly strengthen some of the aspect of the attack vectors that are currently possible on the on-Earth TEs, and try to build on the trust assumptions we have and provide interesting functionality. So overall, the goal is to provide a space computer, basically that will be providing confidential computing to the users, either when it comes to smart contracts deployments that will be possible in the future, or also have individual aspects that we envision for example, for custody wallets or other type of solutions. So definitely there is still a few things we have to flesh out, but the unique primitive of the space TE that is allowing us to have software aspect that will be deployed and programmable as well, together with the physical isolations, are something that I think would bring a unique primitive that we can build on for the future. Yeah.
That's pretty cool. So yeah, now we also have TEs as a space as the use case for us, adding one more list of use cases to the TE world. So yeah, sure. Automata uses the overall TE coprocessors. They generate this on-chain attestations for verifiability and everything. And you guys work with a bunch of roll-ups, right? How is that helping out? The TEs are helping out to improve Ethereum scalability, because what you guys are doing is ultimately impacting the overall Ethereum scalability. Can you also shed light on one of the examples that you guys recently worked on? That would be very useful.
Thank you. So we have heard from all the prior panels on like all the awesome use cases of TEs. But like if we think about TEs, before you can even use the TE, you need to establish that this machine that you are interacting with is indeed like trustworthy, is authentic. If it's space TE, that satellite has to be like in space. It cannot be like some random VM running in Azure or something like that, right? If it's Phala cloud, then it has to be a TE that's running by Phala. It's not like my server running in my basement. So what we do really is to kind of like bring this verification capability onto the chain itself. So we kind of like provide smart contracts and even like guest ZKVM guest programs where you can choose to take the attestation report you want, go to the chain itself and then verify it on chain. This allows us to form this kind of like root of trust, this anchor where, hey, I know that this machine that I'm talking to is indeed a trustworthy machine. And subsequently, I can start like sharing secrets, data, getting outputs from computation from this particular machine. So this establishes the kind of like confidential computation environment that we are interested in. So like you might be asking, hey, what can we do it for? One of the kind of like applications that we were working on last year was with Scroll. So like I'm pretty sure everyone knows like Scroll is a ZK EVM, it's a ZK ROM, right? They have a ZK proof system that is used as the kind of like validity proof for their state transition function. Now, relying like ZK proofs are awesome, they're like really nice. But the thing is, relying on one single thing, like can you imagine you rely on the safety of your entire protocol, all the TVL that you have, all the millions and billions of dollars on one single mechanism.
what if some engineer writing the code accidentally introduce a bug to the verifier or accidentally introduce a bug to the circuit? Having just one single kind of like check is insufficient. This is where TEs can actually come into play. TEs can act as a kind of like alternate proof system where it actually helps to kind of like make sure that, hey, there's nothing wrong with the ZK proof system. Another kind of like application that we have is actually a collaboration with World Network for their AMPC protocols to kind of like to check your iris code. So it uses an MPC protocol, but there's this risk of collusion because the MPC protocol assumes like an honest but curious adversary. So in this case, by using TEs, we can actually help kind of like ensure that the protocol is actually being followed. And yeah.
Thank you, Joa. Moving on. So far our panelists have shared what are the different use cases of TEs and how are they leveraging TEs. So going a bit ahead, would love to know what use cases are getting unlocked because of the way your protocols are designed, right? So let me start with Benjamin. You guys are working on the overall monetization for content creators, and how are you leveraging these for that, and what value unlock does that do for the content creators?
Right. Oh, yeah. Sorry. 1 2 1 2. Okay. Maybe should I remove this? No. Oh, it's not smart. Okay. Yeah. So TE is one of those privacy enhanced technologies. So we always equate privacy to confidentiality. I think privacy should also be related to ownership. The reason why I'm saying this is that when you think of, well, for instance, if I take the example of my email address, the reason why I don't want to share my email address with an app is not because I don't want to reveal my email address. My email is like very boring. I probably had, when I was a teenager, I had some email addresses I wouldn't want to share. That's a different story. Now, the reason why I don't want to share my email address is because I don't want to trust you to first unsubscribe me if I ask you to unsubscribe. I don't want to trust you to not share my data to others. So ultimately, privacy, I feel is mostly equated to ownership of your own data. And so this is true for sensitive personal data. It's also true for the fruit of your labor. So like your data models, the data sets you're putting out in the cloud with AI agents now, it's more and more important. I know one use case we have with this app called Bridge 23. They are AI agents that works in team collaboration in the enterprise world. And so obviously data sensitivity is a big thing. And also finding a way, they're using our TE technology to help monetize the data sets that will be used in these AI frameworks. So that's where a privacy technology can actually be used for monetization.
Thank you, Benjamin. So going on to the next one, Phala has been emphasizing a lot on ROI. And these, how do they provide the best ROI for in case of privacy and security compared to other privacy preserving techniques? Would you like to take this one, Marvin?
Yeah, thank you. First of all, sorry for being late. I'm having a backend panel. So, like we've been building 40 solutions for a lot of time, like you guys too. Setting privacy features is extremely hard, and basically no one will best by use our service because just the privacy. So I would say TE can bring two kind of benefits. One is privacy. The second is verifiability. And today, like our major use cases, we talk with a lot of customers, and most of them on board or use our solution because of verifiability. So, for example, for now, there are two major kind of target group of use cases we are serving now. The first group is AI agents. I already addressed on. But if we break down like why these agent builders need to use TEE, the major answers are either they are building autonomous AI agents, which means the AI can be proved as AI. You know, like XSpeed is a very smart, data market analyzer agent. A lot of people ask me, is it really driven by AI or there's some smart, people behind the Twitter account? The only way you can prove that it's driven by AI is to wrap out the agent framework inside TE. Second agent use case is unblockable AI. Whenever the AI agent is controlling your money, powered by key, can somehow protect, vulnerabilities. And besides the AI agents, another typical use case is AI infra. But I'm going to stop there. And our solution, how we different with the others, we got two products running on. The first one is actually open source SDK called DStack, right? It's open source. It's not vendor lock-in with Phala. You can use the SDK to operate in any TE server as you want. You can run it in Marine, run it in iExec and Oasis. So we hope that can happen. It's not vendor locking our service. And another open source project we're working on is called Private ML SDK. It's sponsored by Near protocol. So that is aimed to use the Docker to drive the AI models running in H100 or H200 within GPU TEs, and it's also open source, not vendoring locking in our service. But of course, we are also providing the TE cloud computation services and many of our partners here. Yeah.
Thank you, Marwan. So, what to Philip, given that you guys are building something pretty novel in the space and you're using TEs for that, what are the different set of challenges that you faced in this implementation? And how did you circumvent them or how did you overcome them?
It'll be a long list, so I will try to think of. Yeah. So when it comes to that, of course, the aspect that we cannot see as the vision is to make sure that some of the mistakes that we see how the infrastructure is being built on Earth, we don't try to reproduce those type of mistakes. So this is definitely something where we are always thinking on how can we make it better. This is something that we hope to project into our infrastructure and also into our protocol. So this is something that we are always working on. And when it comes to the day-to-day challenges we are solving, it's starting with fundamental things like how the infrastructure can be designed. How do we make sure that our protocol can accommodate for the current specification, but also try to be thinking of maybe 3, 5, 6 years ahead, depending on how the infrastructure will be evolving, because we start to see that as of now, we are computational constraints, but also communications constraints. But we see that the far future, not maybe hopefully so far, in the next 3-5 years, can be very different when it comes to, for example, communication via Starlink or other type of providers that can unlock very different type of scenarios and use cases that we have to accommodate for already now in our design. So that part of the uncertainty along the way is something that we are definitely putting a lot of thought on how to make it sure that this will not be something that we can later on stay locked in, but have the future proofness in mind as well.
That's pretty dope. So yeah, looking forward to that solution whenever that's available. Bernard, so just wanted to understand, you are a L1 privacy blockchain, so you do unlock specific use cases compared to someone who doesn't provide privacy as a baseline. So what are those use cases that are made available because of the approach that you have taken?
Yeah, I mean, I probably start with use cases we have already more or less live. Like the biggest use case most maybe know is Ocean Protocol with the predictor app. So their AI models predict prices and put them on chain, but private. And like if you want to have the price earlier than it gets actually published, or like before like the time actually comes in, you can subscribe to this AI models to get the price earlier and profit from it. And yeah, this is not possible directly or not so easy with other blockchains. Surely maybe you could build some CK stuff on other chains to maybe build the same stuff. But with Oasis, it's far easier. Like you can just build your Solidity smart contract, just make private variables for the prices and deploy it. Yeah, it's really easy with Oasis Sapphire. The second use case, which is not specific like only for our chain, is for example Illuminex. And Illuminex kind of built a wallet where you can like you manage your wallet on chain on Sapphire, but you can actually manage assets like Bitcoin with this wallet, because like you can actually hold a private key on chain, and you can also sign on chain on Sapphire transactions for different signing curves. So like that, you can build like a cross-chain wallet with smart stuff on Sapphire. Which makes it very easy also then for AI agents to have like a cross-chain wallet to not only like trade on one chain but trade on multiple chains. And the third is also a use case which goes into AI agents. Imperial, for example, like they kind of use this infrastructure. They like we were talking a lot of the engineers who were asking like, oh yeah, how can we sign actually transactions for Solana and stuff? And so like they try to migrate now quite of their infrastructure to Sapphire.
So yeah, in short, a lot of cross-chain capabilities for AI agents because the whole key is on-chain. Yeah, that's pretty cool. Yeah. Finally, our last question to Chua. You do quite a bit of modular approach with how Automata has been built in. So how are you looking at the T's fitting into the overall modular framework, especially when it comes to your multi-prover ecosystem? Like you briefly touched upon it in the previous question, but would love to know a bit more in detail in terms of, because that is one of the things which helps roll-ups to move from stage 2 to stage 1, right? So would love to know a bit more there.
Okay, so the thing is that we are kind of like pushing this idea of having like modular components. If you think about it, we have heard a lot of like T use cases. We can use T use cases to do key management services. We can use T services to do wallets, communication, Twitter, Discord, LLMs, multi-provers, NPC nodes, so on and so forth. But so if we think about it, actually each of these component, like each of these use cases can actually be kind of like designed as a particular module or component that you can fit to a kind of like a set of operators that some people might, due to certain legal concerns, they might not want to host a wallet, for example, but they are okay, say, running an LLM. Some people might say that, hey, I just want to deal with all the social stuff like Twitter and so on and so forth. So with all of that said, this modularity allows us to kind of like isolate and compartmentalize all these different use cases, and then make use of a TE to verify that, hey, this particular functionality that I'm trying to host or I'm trying to access is indeed trustworthy. And you kind of like wrap it all up. In our case, we actually we run an eigenlayer AVS. So the operators would actually have, depending on which modules they actually select to run. So for example, they can choose to run scrolls, multi-prover, or linears multi-prover. So if they have that particular module on them, then we are able to kind of like give them, what's that called? Work basically to perform. Now, this actually ties in, like, because we are using like eigenlayer as the AVS, it actually allows us to have some sort of economic security actually to underpin the services that the TE operators are providing. So, for example, like one thing to note is that TEs are good for confidentiality, TEs are great for integrity, but TEs can't prevent like liveness issues. So with basically all the economic stake on the AVS, we can make use of that to kind of like at least give a level of economic security to the liveness of the TEE. So I think this kind of like wrap it up into in our mind a complete solution where we have the TEs, we have the modularity, we have the confidentiality, integrity, and the liveness that is kind of like protected using economic security. So yeah. That's fine.
Yeah, thanks a lot for all the panelists. So yeah, thank you for all of your insights. Everyone, round of applause for all the panelists. And from not knowing what these are during last week that wherein we had to explain it's not a t-shirt merchandising company, to having a dedicated tea afternoon party with so many builders and developers trying to learn more about these. We have come a long way. So all of the projects here have put in a lot of effort to educate and create awareness. So yeah, round of applause to everybody and to yourself for being here and learning more. So yeah, thank you. I would like to call Martin for the next one.
Thanks. Let's go. We are about to start our second panel. But first, I have a limited edition hoodies to win. We done only 100 of these. I have only one question, and the first one can answer will win this one. When iExec release its white paper, the year. When iExec release the date, I let you 5 minutes to think. The first who has the answer wins the hoodies. So let's go. We're gonna start our second panel. I need my panelists, William, Lisa, Zheng Long, and Eng from Phala. Non, je l'ai bien. Okay, I need my speakers. Come on, William.
If I was not here, then it's me.
Oh, you are doing the second panel?
Yeah.
All right, cool. Okay, let's go. So welcome newcomers. I think if you attended the first panel, you know everything about these. If not, too bad. So let's go. You can sit. Yeah, sure. No. We can sit. So I will let you just 30 seconds to introduce yourself. We know a lot about our company, not Secret Network yet. So 10 seconds each, and then bring me back the microphone.
All right, sounds good. I'm Will. I'm Ecosystem Growth Manager at Oasis Protocol. I think everyone learned a little bit during the last panel, but we are a TE-focused layer 1 network that's also focusing on, I guess, off-chain compute and confidential compute in the AI space.
Hi again. My name is Zheng Long, Chief Geek of Automata Network. So what we do here is we actually build a machine attestation layer. Yeah.
Hi, I'm Lisa Loud. I'm Lisa Loud from Secret Network Foundation. We are building a confidential computing layer 1 blockchain with TEEs and have been on mainnet since 2020. So kind of OGs on the TE space.
Hey everyone, super happy to be here. I'm Hang Yin from Phala Network, CTO and the co-founder here. We built the AWS, but only for Web3. Because whenever you have anything that can deploy on AWS, throw it into our cloud, you automatically get integrity and privacy, and also it's provable. So yeah, build on top of TE, and super happy to discuss all the questions here today.
Great, thanks. I would like to make this panel a little bit more spicy. So if you are hearing me, if you are not agree about something that our speaker said, you can shout, I'm not agree, and you will have 10, 30 seconds to come and explain why. If you are all agree. You are all agree? Yeah? Okay. I don't know if outside they're hearing me. Let's go. So as you may know, TEE, it's not new technology. We are using it in Web2 for a while, but they rely on certain trust assumption. So my question is, can you explain what those and why it's matter? And I have not specific questions, so you can grab the mic when you want. So I don't know, random selection, William.
Yeah, I think, for a long time, our industry faced, I guess, FUD in the TE space based on these trust assumptions. The big ones were like side channels, Intel being like the only provider that people wanted to use, things of that nature. Sorry, can you repeat the last part of that question?
Yeah, can you explain what those?
Okay, yeah, so side channels. Yeah, so side channels are basically different exploits, whether it be hardware or things like access pattern leakages and things of that nature that might reveal privacy. For me, though, I think that the biggest thing that was missed for a long time and is currently being understood better is that the guarantees are still far greater than any other privacy solution currently offers, and also is practical and usable today. And so, as an industry, with our great partners here, we're all working to, address these concerns, make the industry safer. But at the same time, we're building towards, a more private Web3 that's practical and buildable today.
Next question.
Yeah.
Next question, sure. Okay, cool. Because you talk about side channel. We have secure roots of trust. We've got remote attestation. But let's go on the next question. I think there is a clear trend. Actually, it's AI, and even more with TEE, GPIME stuff. So some people think that AI and Web3 are and blockchain are not compatible, because blockchain it's trustless, it's transparency, and AI it's actually centralized with big tech company. What is your thought about it, Lisa? Maybe.
I do not agree. I don't think that Web3 and AI are actually in competition at all. I think they're very compatible. We're working on decentralized AI, and I think the future of AI could bring us to a really great state of humanity where we have health and good air and everything, or it's so powerful it could take us to the brink of extinction. So what I would say is that the only way to have AI that is good for humanity is to decentralize it. The only way to decentralize AI is to have confidential computing built in. So that's why I do not agree.
Yeah, I can add 2 cents. So around how to decentralize AI, then we can think about what is the supply chain of AI. So we have an AI agent. AI agent is going to consume the LLM, so like an AI model inference. And where does model come from? It comes from the model you trained, so training. And when you train the model, you also need the data, right? So thinking about if in the future we can have the best model, then we can sell the model not only to the Web3 people, but also Web2 people. That's what do you mean? Like we can have the best AI for the entire humanity, not just for Web3. Then how can we make this realized? First, we need to better data. And we see projects already working on that, like Vanna and other teams. Then they use TE to protect the validation of the data. Second, training, right? You want to make sure the training process is also verifiable. Then GPU-T come here in the play. And then inference, also GPU-T, you do the inference on GPU-T as well. You get it verifiable and privacy preserving. And finally, like AI agent. So every part in this supply chain can be protected by TE and the TE GPU. So that's like why I also don't believe like a flat blockchain has nothing to do with AI. It actually solved the biggest problem of AI.
Thanks. Yeah. So I guess echoing what my esteemed colleagues and coworkers have thought, I think that in AI is an extremely powerful technology, and it's sort of as powerful as the data that it can consume, right? But one of the scariest things about AI is that like we don't necessarily know how it works or like how it comes to the inferences it comes to. And so why blockchain is extremely synergistic with AI is that we provide verifiability. We also provide guardrails. You can use smart contracts, you can use blockchain, one to come to consensus, but also to set the parameters where the AI can run. This protects user data, this protects personal information and confidential compute, like Lisa said. And so the scariest, most dystopian future is an AI, in my opinion, that has access to everyone's data, and there's no guardrails for that. No one has control of what they own, and that's sort of the solution I think we're all working to solve.
Oh, yeah. Sorry. Just 30 seconds. So I only have 30 seconds, so I'll do it very quick. So just to add a little bit on like what Hang has said. So I don't think people realize how important data is in this particular AI age. And like moving forward with more and more generative AI, right? You'll get more and more data. How do we know whether a data is actually a real world a piece of real world data or AI generated? This is where TEs actually come in. This is one thing that no other technology can do other than TEs. I will put my head on the block here. Why? Because, for example, like if we have some real world data, we need to have some way to capture the data. There's no way you can use a ZK thing to capture that data. It's just impossible because ZK circuits are like an abstract kind of notion. You need something physical, and this thing is a TE. It actually acts as a root of trust to say like, hey, this data actually originates from me, either from the blockchain or from my phone or from a camera. And then from there, we can make use of it to kind of like differentiate fake AI generated data from actual data. This helps in the training because, you know, like rubbish in, rubbish out. If you train using AI generated data, the model is going to be like really bad. It can also help to differentiate between like maybe deep fakes and actual photographs. So it is going to get even more important.
You're totally right. But let's get a bit more technical. Don't be afraid. TE is a hardware-based technology. We know there is some weakness. How we could, in this combination with AI, bring more trust? Which solution we could find to bring more trust and find some way to mitigate those weakness?
Now we're talking about attestations. So what are attestations? Let me just ask, who knows what a smart contract is? Okay, you know what a smart contract is. So if you have the combination of hardware isolation, as you said, with the TEs, and you have an attestation, you have a quote, you actually have any program, any software can run as a smart contract on steroids. It takes every single Web2 application that is possible and makes it as though it could run as a smart contract. It has that immutability and that trust that you want in smart contracts, which is why blockchain arrived in the first place. So what is an attestation? It's actually making sure that every step along the way is secured. You get a key from the hardware. You make sure the IP address is attested to. You make sure that the VM, every single step along the way, the application, you need to audit things in order to make sure that those parts that you can't attest to, like a hardware attestation, you need to make sure that every step in the app is secure and you know where it came from. Once you do that, you actually have end-to-end attestation. And that's when they talk about attestation, that's what it means.
Yeah. So I guess in terms of, I guess the question was mostly about like how can we make sure that TEs are more secure in the future. That's basically the gist of it. At least from the Oasis perspective, the thing that we think about is defense in depth. Adding a key manager that leverages multi-party computation so that there's no one validator that has access to all the encryption keys and things of that nature. Additionally, I think the thing that our industry can do the most, and it's not maybe up to the Web3, but getting more TEs, getting more accepted than Intel SGX. It'd be great if AMD offered the same level of remote attestation that Lisa was talking about, things of that nature, so that we can combine it with blockchain technology, and that we can have sort of redundancy. I guess one other thing that we think about Oasis is like, we also have primitives in Web3, like proof of stake. You can have stake for validators, and if they overstep their sort of what the user expects from them, or they overstep what access they should have, maybe by a side channel attack or something along those lines, then they lose their stake and things of this nature. So we can incorporate more and more and more defensive options to make it extremely unlikely that these attacks happen and that users feel more protected. So, for example, if you had like a key manager where one key used AMD, one used Intel SGX, and one used some RISC-V type, RISC-V type TE, right? Well, now you can't just exploit the Intel SGX version or the Intel TDX version or the AMD version. You have to exploit all three in this multi-party way in order to expose the secrets. And so, yeah, I think that basically just exploring more defensive depth options so that users feel protected is the way of the future. And I think that all of our protocols have been exploring these ways, and I feel pretty secure with what we've all been doing.
It made me think, like, are we adding more layer of complexity? Like, you want to add some protections more and more, because TD is an amazing technology, and we want builders that use it easily.
Yeah.
So my first question is, do we add more complexity, and how sorry, this question was not in the list, but how, with your project, are you facilitate the use of your technology?
I guess, like, as that pertains to what I was just talking about, I don't think it actually increases the complexity at all. From the end user, I think that's all abstracted away. Maybe for the validators, maybe for the people running the infrastructure, it's a little bit more complex, but that's their specialty. They're good at that. For the end user, I don't think it results in any increased level of complexity. It only increases security. I don't know if anyone has any thoughts.
So I just mentioned it a little bit during my previous panel session. So, like, when we think about, like, we have to use TEs, we have to use NPCs, we have to use ZK, layer it with all the different kinds of access control and on-chain verification. It's so complex. But if you think about it, that's if we want everything. We can actually compartmentalize the whole thing into different modules. And the kind of like complexity per module is actually very reachable. So it's not that complex. You can take a big complex problem, break it down into smaller problems that is more amenable. It's the kind of like classic divide and conquer strategy. So I don't think it's complex for users because it's abstracted away. For builders, we can always kind of like break it down into smaller components. The smaller components make it easier to implement, easier to verify, easier to make sure it is correct. So yeah.
Actually, I have a question for you guys. Do you think like a ZK EVM or some problem running in SGX, which one is more complex? ZK. Yeah, and if say one related thing is interesting to think about is, I'm not sure if everyone here ever think about what if the implementation of some ZK solution actually has some problem. the hardware can have problem or software can have problem, but eventually anything created by human can have some problems. So the more complex, the more easy it can screw people up. So this is one point I want to make. Another point is I can add to the complexity for users a little bit. So back in 2 years ago, some team, well, it's actually Flashbox. They try to port the Ethereum client into SGX. It takes them roughly half a year to do so. And after doing that, they still face a lot of problems. But you know, the technology is evolving. And in last year, with the latest generation of the TE, the same thing can just be done within 2 weeks. So this is the number from Flashbox team. And now if you do the same thing with some SDK, like we have the open source SDK or our managed cloud, all you need to do is to copy and paste your Docker file into the cloud and click deploy. And it's just a matter of a few minutes. So that's what people already mentioned, like we abstract all the complexity out so that the users, you don't need to care about all those complexity. And almost all the complexity is actually created to ensure the whole process is secure enough. So yeah, I think there's a balance and we can manage it pretty well.
I would like to focus a bit more on secret network. You wasn't there for the first panel. Let's talk about the future. So we talk about AI trend. There is Swarm, and it's grow really fast. I would like to know how secret network is riding this trend with AI.
Secret Network is building confidential AI infrastructure along with our friends Phala Network. We're very on par in terms of our vision. Secret Network is a layer 1, which is the difference that we have. But we're building the same type of technology. It's basically the confidential AI infrastructure so that large AI companies can build on top of it. And why is that important? It was mentioned in the last panel that if you have an agent, an AI agent that's trading for you, and you don't know who's behind that, that could be a rug. It could be a scammer. You don't know. It will be a scammer unless you build your agent with TEs. And Phala has done an amazing job of demonstrating how that can work. Secret is doing the same thing, showing that attestation for the agent, so that you can tell that this agent is actually being run inside a TE and there's no malicious actor outside that is there ready to grab your funds as soon as they're available. And what Secret Network is doing is partnering with larger AI companies. We're partnering with Singularity and Fetch and Autonomous and Aether. Look, these larger AI companies that are providing decentralized compute and AI, but they don't have that one element of locking that environment so that nobody else, isolating that environment so that it can't be corrupted.
This context. Yeah. So the one thing I just wanted to add to what Lisa said, which is 100% accurate, is just like, I guess, context from maybe someone who's been like a Web3 degen for a while. But I think current AI solutions, AI agent solutions, are very centralized. And like she said, they don't involve. We don't know who owns the private keys to these AI agents, especially if the agent takes control of your private keys and acts on behalf of you or anything like that. And what Web3 has taught us is that whenever a solution comes out, it often comes out centralized. We saw this with DeFi in the beginning. It will be exploited. It will result in rugs. And you know, the ideal future and the one that we should be looking for is to prevent these things from happening, to build with a vision of how we can stop these rugs from happening before they even happen. And this is what CEs offer. They allow you to trustlessly know that this AI agent is running in a black box, in an enclave, and there's no one person who has control over it. And as Lisa said earlier, have the remote attestation that means verification on chain that there's absolutely no way that it could be exploited by some sort of centralized control. So I just wanted to expand on that. I don't know if you had any other thoughts to add or.
Oh yeah, sure.
I just wanted to say before we get to the end that we're running with Phala. Actually, we're hosting a new podcast called Spilling the Tea. It has not been released yet, but Zoe and I are interviewing a lot of big names in the space because we want to bring some of this knowledge to the general population, just so everybody can understand TEs at a kind of every person's level.
Great, great. I have a tough one because with blockchain, you everybody knows the trilemma, but I have a concept with privacy, the quadrilemma. Like there is the builder, there is a tech provider, privacy tech provider, there is the compliance, and shit, I forget the fourth one. Okay, quadrilemma. So tech, end user, builder, compliance, and tech privacy provider. The question is, with TE, we can compute everything privately. How this technology can be compliant with the new regulation, all the new laws that are coming? Tough one.
I don't want to monopolize, so other people can go.
So no one wants to take this hot potato, so here I am. Wow. Okay. Anyway, like, you know, a lot of people think that, hey, like, TEs actually help provide confidentiality to the data and computation that we are doing. Therefore, regulators would hate it to the core because now they can't like spy on you anymore, right? Actually, the answer would surprise you. It's actually the opposite. Regulators actually like TE. I'll give an example. In most traditional Web 2 companies, right, if they want to kind of like work with the government or they deal with some health data or some kind of like what do they call it? Like personal data, personally identifiable data. There is this whole list of like regulations that the regulator will give to the company that they must fulfill. For example, data at rest must be encrypted. Data in transit must be encrypted. So for certain computations must actually be done within the country. Why? Because if you do it, for example, if I have a data center in Hong Kong and I'm based in Singapore, then my data is actually under the like in plain text in Hong Kong being computed. So all these are examples of like regulations that regulatory bodies will give companies. With TEs, companies are actually able to fulfill all these requirements that is set forth by the regulatory agency. So for example, by using a TE, your data at rest is encrypted, your data in transit is encrypted because you can do a end-to-end encryption. Your computation can actually now be outside Singapore or like outside a specific region. Why? Because previously, without TEs, you actually cannot perform computation. You cannot perform computation on encrypted data. So we have data at rest must be encrypted, data in transit must be encrypted, but data during computation cannot be encrypted. With TEs, this can be done. And with that, companies actually have more flexibilities to do things. And regulators, like, they are not evil people. They set certain regulation. Okay, hot take. Okay, they are not that evil. Like, there are certain regulations that are there to protect people. They also want to make it such that companies have the flexibility to actually do what they want to do. And TEs become a very, very powerful tool in this specific case. So yeah.
I just have to needle you a little bit because you said doing encryption, doing operations on encrypted data. And that to me says, okay, FHE, why not FHE? I know the answer, but why don't you tell me?
Why not FHE? Oh man, like, okay. So if you kind of like lay down the kind of like amount of computational overhead that is required for all the different like techniques. So we have like bare metal, we call it 1x. And then we have TEs, we call it like 1.1x or 1.01x, 1.1x. Yeah, 1.1x. Then we have like, ZK MPC, maybe like 10x, 100x, 1000x. There's like a range of it depending on the complexity of the computation that you are doing. But that's the kind of like order of magnitude that we are looking at. FHE, we are looking at probably like 1,000,000x. So can we do it? Maybe. Like if tomorrow there is a math genius that came up with this groundbreaking scheme that we can use that would reduce it by like 3 to 4 orders of magnitude, then yeah, it will be a possibility. But until then, TE would be the kind of like practical solution now. Like we can use it now.
Thank you very much. I've got another tough question. Sorry. We cover every topic, so I have some bonus question. Now, we are building application project for end user. And my question is, DeepSeek leak, and they continue to use DeepSeek. Facebook data leaks, they continue to use Facebook. So my question is, do they care about their privacy, and how we could educate them to realize that there is a big problem to give and train model with our private data, give our data to a big tech? Do they care how we can educate them?
I just want to answer that from one perspective and leave for the others to discuss. So at the beginning, even on Ethereum, people are not always making smart contract open source. But if now you check Etherscan, as long as there is a serious use case, they always have their smart contract validated. So you have the smart contract code, it's validated by a third party, so you can ensure you can always audit the logic behind the smart contract. And why does that happen? I actually asked Vitalik. The reason is the DAO hack. Because people got hurt so hard, they have to come up with a solution to prevent that from happening in the future. On the Web 2, do we have alternative to Facebook? Do we have alternative to, Apple and Google? Probably not. But now with the new technology, TE, and with the new, technology blockchain, it is actually possible to rebuild a lot of things from the ground up as a better alternative. So with the alternative, we can actually build a better internet instead of just relying on the old ones.
I agree, but I think that there will come a moment when we when we have one agent that we're telling everything to, and that becomes our soul. Basically, it knows everything about us. It does everything. It does our travel arrangements. It's our therapist. It knows all of our medical history. There will come a moment when people realize that their soul is invested in this AI, and when they feel that fear of having that exposed, I don't know when that moment comes, but I think that's the moment when people will start to care about privacy.
Yeah, so I might be a little bit more cynical. I do think that eventually people will care. Unfortunately, I don't think people will care before it's too late. I think that the industry has taught us that sort of a leak has to happen. People have to be exploited. People have to feel pain. And I hope, all of us here today are talking about this, are building towards this future, trying to prevent that from happening. But I do think that probably the moment that it occurs is when something gets exploited that no one had ever thought, or no one who was outside of this TE space had ever thought would ever happen. And, it'll be unfortunate, but we will be there and we will have the solutions for the future. And hopefully it'll never happen again after that moment. This sort of reminds me, Sergey from Chainlink often talks about this, is that unfortunately for Web3 to overtake Web2, Web3 must be equal to Web2 in every other aspect, UI, UX, DevX, everything like that. And then that's the moment where people will be like, all right, if it's equal in every other way, plus it offers privacy, plus it offers sort of the decentralization and the self-custody, well, now there's no reason not to use it. And that's what our industry should be aiming for, is to give products that there's no reason not to use.
Yep, I Totally agree. He basically took what I want to say like out of my mouth. Really. Yes. So I mean, other than that, you kind of like ask like why do people kind of like when DeepSeek gets when the DeepSeek service leaks the data, people still continue using the web DeepSeek service. When OpenAI leaks the data, people still continue using ChatGPT. The reason is because there are no alternatives. Like before DeepSeek, actually, there's no like good open source foundational LLMs that are available. So, like, yes, OpenAI leaked my data, but what can I do? I still have to use. I want to use the model, right? Like, there's no other options. Now, actually, with kind of like open source AI, like DeepSeek, their service leaked the data, but we do not need to like use their service, right? We can, for example, run it on Phala's TE cloud, yes, GPU TE, and we are in control of the models. So the sad thing, like the sad fact of the world is that like if you're talking about privacy, security, people don't really care about it until something bad happens. But if you have two things that are equivalent in all accounts other than the fact that one of them have better privacy and better confidentiality, the users are going to choose the one that has that additional features. Like users are really tough masters, but yeah, that is life.
Thank you very much. It was the last question. I think we can make a big round of applause for our speaker. Some of the question was not in the list, so little bit tricky. Sorry for that. Thanks again. It was amazing. And we still have the limited edition hoodie. The question was when iExec released its white paper. Oh, we've got 2017. You think okay, 16 again. Yeah, it's okay. 16, 17. You will have one. Yeah, but I'm a gentleman. Let's make a picture.